So I decided to do just a quick video just to show you basically the entire FPGA development process. So what you see here is basically three pieces of software: the Vivado environment, the Vivado HLS environment, and the Xilinx SDK environment. So the first software package that you need to use is the Vivado HLS software package. So in it, you'll configure the ECHD algorithm. It's all in C++, so it should be fairly familiar to you. Otherwise, you could just refer to either my report or the documentation online. So after you have configured the ECHD algorithm, what you can do is press that export RTL button, which essentially sends the configured ECHD algorithm in basically Verilog or VHDL, and export it into this Vivado environment, which can synthesize the FPGA design and have a look at how it actually looks like as part of a whole system. So after you have done that, what you can do is you can export the design that you have synthesized in this environment into the Xilinx SDK environment. So in this Xilinx SDK environment, what you can do is that you can program the ARM processor and using two USB to micro USB cables, and effectively you can see the result in a serial terminal of your choice, like PuTTY, and you can save it into a text file. It's all in CSV, so it allows easy further processing in Excel or any software package of your choice. So let's start by having a look at Vivado HLS. So this is the Vivado HLS environment. So what you have here, as I've explained this to you before, is that if your source files here and the test bench that effectively tests on the source files you have synthesized. So the first step in synthesizing, effectively compiling to C++ design, is to press this button right here. This is the C synthesis button. So if you press this, you see this message here, starting C synthesis. So when it's done, it'll tell you that the C synthesis has finished and you can proceed. But in this video, I've already done that, so I'm just going to stop this right here. And I'm going to show you the next stage, which you can do some testing, which is run C simulation. So you can press this button right here. You don't really need to modify any options, just press OK. So you can just wait for the C simulation to complete. And as you can see, this is basically the results of the ECHD algorithm. It's subject to the data files I've provided to the ECHD function, if you think about it that way. So it's a function argument I've submitted, like the raw data files, for example, raw data that is being processed in the ECHD algorithm, which outputs this stuff. So that's the C simulation. After you synthesize, if you want to look at the hardware simulations, you can press the CRTL co-simulation button. But otherwise, you could just press the export RTL button and export the Verilog VHDL configuration of your C++ algorithm into the Vivado design environment, which you can see here. So it looks very messy, but what you have to effectively understand is that what you've created in Vivado HLS effectively is exported into this environment. And so this is essentially your C++ algorithm. And every time you modify the C++ algorithm in Vivado HLS, there'll be a message here that tells you that this block design is out of date and asks you to update. And so you just need to go through the update process and everything will be configured. So this looks really messy, but you really just need to do a few things right here. So the first thing you have to do, especially if it's your first design, is that you have to find something called sources. And what you have to do right here is just right click this and create a HDL wrap. So this allows Vivado to manage your project essentially. So just let Vivado auto-update this and just press OK and you're done. I should probably mention that this diagram right here, you can have access to it by just pressing this open block design diagram. You'll have access to this. So as this video, I'd just like to show you how to go through the entire synthesis process. So the next thing you have to do after you have your design in place with all the files I've given you, the next thing you have to do is validate the design to make sure that there is no obvious errors like a clock signal on being driven. So after you validate the design and you verify that it's correct, there's essentially 3 more steps. So you can run the synthesis, run the implementation, and generate bit stream. But it's not really necessary to just click these buttons one by one. You can just directly just click generate bit stream, and you see something like this. And what you see here is the number of jobs that you can execute concurrently. So as my laptop, I have 4 logical threads, so I can execute 4 jobs at once. So it depends on the processing power of the processor, essentially. So just set the configurations, press OK, and then you will see some loading screen kind of thing that tells you that the bit stream is being generated. It'll take about an hour or so, especially the first time round. After you've done with that, you should see something called write bit stream complete, and that tells you that the process has been completed, and you can now program the FPGA. So the next step you have to do is you click File, go to Export, click Export Hardware, and it's very important that you have this selected, which is include bit stream. Otherwise your design will not work. So make sure you include this when you're exporting the hardware. Press OK, and then you see this message. You just need to press yes, it's fine. And after you have done all this, it's basically time to launch the SDK environment. So if you remember from the start, I mentioned there's 3 pieces of software: the HLS software, which you configure the ECHD algorithm, this Vivado design environment, which you see here, and finally the last piece of software is the Xilinx SDK software. And this software you program the FPGA using 2 USB to micro USB cables connected to the UART port and the JTAG programming port. So what you have to do is that after you exported the hardware, you have to click Launch SDK. So Launch SDK, just need to press OK. And what you see is something along the lines of this. So this is basically the SDK environment, which you can program the ARM processor. And the FPGA, with the FPGA bit stream that you have generated here, if you recall. So going back to the SDK environment, so what you have here is a project, classic Eclipse project, and over here you can see the Butterworth coefficients that we've been calculating, and this main file right here, which basically contains a bunch of logic that controls the ARM processor and instructs it to do a couple of different things, but you don't really have to worry about that. I guess the important thing you have to notice is that there might be this thing which is called linker script, and it might tell you that the linker script is not updated automatically. The user has to update it manually. So what you have to do is that you have to go to your project file, right click this, go to generate linker script, and then you see something along the lines of this. So in this environment, you need to make sure that every single of your configuration settings is the same as displayed here. Otherwise, it will not work. So most importantly, it's probably the heap size and the stack size. So make sure both of these are set to 32K, and make sure the heap and stack is placed on the PS_7 RAM. And then after you have checked that these are right, just press generate, just press yes. So now it has been generated. So the next step is pretty simple. You just need to program the FPGA. So press program FPGA, select the hardware platform. It's normally 0, but in my case I've done some modifications, so it's 2. So this is the hardware platform you'll be selecting, the bit stream, and just need to press program. So before you press program, you need to make sure that there are 2 USB to micro USB connected to your FPGA board. So you just need to press program, and your FPGA will be programmed with the bit stream that has been generated in this environment. The next step to this process is actually just to run the algorithm itself on the ARM processor. So you just right click this, or right click this run as launch on hardware. And before you do this, you need to make sure that you have basically a serial terminal program set up. So in my case, I'm using PuTTY. So what you have to do is that you have to load the Xilinx SDK into this environment. I've saved it as a setting just for convenience. So the port is COM4 and the baud rate is 11,500. But you can configure this. Essentially, this is a bit quick. If you want it a bit slower, you can do that as well. But I think what's perhaps most important is this logging environment. You need to make sure that you have set this up correctly. And you have a log file that essentially stores the data that you see in the serial terminal. So I can just show you an example of the log file. So this is an example of the PuTTY log file. So it's a PuTTY log file. And this is essentially the output of the ECHD algorithm. The raw data is here. This is the real component. And this is the imaginary component. And I think that is pretty much it. So all you have to do is program the FPGA. Make sure your PuTTY settings are right here. It's correct. And just need the final step of running on hardware. And that's it. Thank you.